Now we're going to practice the rules we didn't get to use on the previous day with, I believe it was rules 1 and 2. So what we're going to do is we're going to expand and then we're going to simplify them into one log. So for example, this one, log 8x y to the fourth. So first what you want to do is you kind of want to look at it and say, how many things are multiplied together? Well, I have this one multiplied by this one multiplied by this one. So I'm going to have 3 logs. First, I'm going to have log 8 because that's the first thing that was multiplied. And then when we say multiply, we mean add with logs. So add log x, add log y to the fourth. All right, let's see if we can simplify some more. Well, one of the rules says if I have a exponent, it can actually come to the front as a coefficient, so I can do that. All right. Now, let's kind of see if there's anything else I can do. Well, this 8 is kind of interesting. 8 is the same as 2 to the third. So what I can do further is change 8 into 2 to the third. And now I have another exponent, so then I can also put it in the front as a coefficient. All right, so this is probably the most expanded form you can get without going way crazy on this. All right, let's look at number 2. So I'm gonna expand it, and looking at this, you're looking for inside the log what is multiplied or divided. I have this thing divided by this thing. I have something added in here, but adding is not something I can actually expand, so I'm gonna just leave that alone. I do have the square root here, so I'm gonna have to change that first. All right, so this is natural log. I have x squared plus 5. Square root means 2 to 1/2 over x. Okay, so one thing you want to make sure you don't do is you don't cancel this. So that's killing a cat, so don't do that. All right, so now what I'm going to do is I'm going to take care of that dividing first. Dividing, remember, so I have 2 things divided, right? I have this thing divided by this thing. So that means I'm going to have 2 logs that are subtracting each other. All right, next I have an exponent, so I got to move that exponent in the front. Now you might ask, oh, why don't you distribute? You cannot distribute exponents when there is a plus sign or minus sign in between. If that is not present, if you don't have anything, yes, you can distribute that 1/2 if you want. If there is something there, you cannot distribute. So there's nothing we can do. We have to move that 1/2 to the front. All right, now you might say, can I distribute this log? No, you cannot. There is no such property as distributing logs. So this is at the best that you can do. This is as expanded as you can have it expanded. All right, number 3, this is to simplify those 2 logs into one log. Now, you can't simplify them when there is still a coefficient in the front. So what we want to do is move that coefficient as an exponent. The question is the exponent for what? For x, for y, or for both? The answer is for both. It's always an exponent for whatever is inside, which is all of them. Okay, so make sure that you always give it to everything that's inside the log. So this becomes natural log x to the 5th minus natural log xy to the 2nd, like that. Okay, minus means divide, so this is natural log x to the 5th divided by xy squared. All right, we're going to simplify this some more. Natural log x to the 5th over. This time you can distribute because you can see there is no plus sign or minus in between, so we can distribute the exponent. So this is x squared, y squared. All right, let's simplify some. some more, you can see that this x to the fifth over x squared can be simplified. So natural log x to the third over y squared. So this is the answer. Now, oops. If we want to evaluate something like this, log base 4 of 7, we want to figure out what that number is. We cannot actually simplify this, right? Because this 7, no matter what I do, I can't make it into a base of 4, so I can't actually solve this. So what should we do? Well, we have this rule here called change of base. So when you have log of a base of x, and they cannot, for any reason, or for any method at all, become the same base, then what you can do is you can arbitrarily pick a base that you think is easier for you to solve. Log base A, like so, but they're divided with each other. And then what you're going to do is you're going to put this x here, and then you put the b here. Okay, what does that mean? And what does it mean when you say arbitrary, or when I say arbitrary, pick a base? So for example, this one that I cannot solve by hand, what I'm going to do is I'm going to pick a log that I think is easier for me to solve using a calculator. So I'm going to pick either the common log or the natural log, because they are buttons on my calculator I can use. So I'm going to have a log divide by log. Next, I'm going to put whatever is inside the log that goes in here, and then whatever that was the base goes inside here. And now I'm going to use my calculator to figure out this answer. Okay, so log 7 divided by log 4. 1.4037. When you do this on the calculator, make sure you put log, and then it's automatically going to open the parentheses, and you put 7, but you remember you got to close that parentheses. If you don't, the calculator is going to make a mistake. Okay, divide, log, and opens the parentheses again, put 4, and then you don't have to close it since it's the last of your expression, but you can close it as well. And then it's going to give you the right number. All right, let's go ahead and have you practice log base 3 of 8 and log base 7 of 3. So pause the video, write the answer, and then come back and check it. All right, here are the answers. Now you might want to, you also may have a question of saying, do I have to use common log? Can I use natural log? Yes, you can do the same thing here. You will get the same exact answer. So it doesn't matter what log you use, you just need to use the same one. All right, let's go ahead and practice this. You're gonna rewrite this time. You're not really using the calculator for anything. You're just going to change this expression so that it only has common log. What does that mean? Well, you see here, this expression has a base of 2. So what I'm going to do is I'm going to use change of base, so it only has a base of 10. So I'm going to do one as an example. This is log x over log 2. So now both of them have a natural log base. Have a common base. All right, so let's have you try number 2. Change it so it only has a common log, so you only use common log. Okay, you probably got to this point. This is probably as far as you can go. However, there is one more thing you can do, and I'm gonna show you because it's a trick for later. 1 over 2 is the same as 1 divided by 2. So you can actually just say this is log 1 minus log 2. Remember, something divided by something inside a log is as if it's a log minus log. Now, log 1, what's log 1? Well, any log of 1 is 0. So this part is really just 0, so that's gone. So you have a negative log 2. All right, so now let's go ahead and practice. So same thing as before. Let's do this one. Okay, so we're going to figure out the transformation from natural log x and sketch. The sketch part is not that important because all the graphs kind of look the same. All right, let's go ahead and change this. So we're going to use change of base so that this log becomes a base with natural log. All right, so this wants a natural log, so we're going to just change it to a natural log x over natural log 5 using the change of base formula. But they want a transformation from natural log x, meaning this is my parent function. So what does this thing do? Well, let's rewrite this. This natural log x over natural log 5 is the same as 1 over natural log 5 times natural log x, right? Oh, I'm sorry, I said x. I wrote 5, right? So, for example, x over 2 is the same as 1/2 times x, right? It's just another way of writing it. So, I know this is my parent function. This is something that's multiplied to it. So that means this is the vertical stretch or compress. Well, which one is it? Is it stretch or compress? I don't know. I'm going to have to use my calculator to figure out what 1 over natural log 5 is. So use the calculator. And then I figure out that 1 over natural log 5 is actually 0.621. So 0.621 is less than 1, so this is going to be a vertical compress, or you can say shrink, by, you can say 0.621, or you can say 1 over natural log 5. All right, I'm going to show you one more, and then you're going to do number 3 on your own. So same thing, we're going to change to a base of natural log. And so this is going to be natural log x over natural log 1/4. All right, so I showed you this before. 1/4 is the same as saying natural log 1 minus natural log 4, and then natural log 1 is 0. So this is natural log x over minus natural log 4. Now we're looking for the parent function, so I gotta get that natural log x by itself. And then what I have multiplied to it is just 1 over natural log 4 with a minus. All right, so there are 2 transformations on this. One is this negative. This negative is on the outside of the function, so we'll talk about what that does. This 1 over natural log 4, I have to figure out what that number is in order for me to figure out if it's a compress or stretch. So again, I'm going to use my calculator. 1 over natural log 4 is 0.721. So that is less than 1. So this is going to be a vertical compress by 1 over natural log 4. And then that negative, because it's outside of the function, that is reflect x-axis. All right, let's have you try number 3. Pause the video and then come back and check your answer. All right, go ahead and check your answers.